Hello, everyone. So we have another purple comet problem. So this was a middle school question, number 20, which meant to be, most challenging problem on the test. So it's given that there's a square, the side length is 6, and the circle X, Y, Z are congruent. So let's kind of highlight those just to start with, right? So the circle X, Y, Z are congruent, and with the center inside the square such that X is tangent to both X two sides like AB and AD. So X is tangent to both AB and AD, and Y is tangent to AB and BC, and then Z is tangent to CD, and both of the circles X and Y. And based on this, what we want is just the radius of the circle, which is the same as the other circles anyway. So like to start with, like we can try the most general approach, I would say maybe drawing a square first and adding circles based on the given stuff. So let's say this is one of the circles. Let's say this is called X, and then we probably expect another circle and the third circle. So since we want to have three circles, a lot of tangency going on, so assuming this is going to be tangent to this, and that's tangent to other two, as well as the part of the square. But when we do it this way, there's something wrong going on. So if I connect these, right? So that will be R, 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 that will be R. So if you take this segment, which is also R, and then this is also R, so which means if you were trying to connect this guy right here, because this is identical, so that height will be just in the middle, and this segment is also radius. So meaning that this whole thing is the side length of the square, which we know this is 6, but we do know this is equilateral triangle, which will force this is 60 and this is 30. And if you remember the 30, 60, 90, this is going to be like half of the hypotenuse, which is R is given. So which is going to tell us this segment, which this is height, is going to be R root 3. But in that case, we have R root 3 as the height plus R and R, which is 2R, equals the side length, which is 6, right? But that is also same thing as this is R, this is R, and this is R. So which is going to equal to 4R. So when you look at this one, we have 2R plus R root 3 equals 4R, which will force this number to be 2R, but there is no way to do so, which tells us then the figure shouldn't be like this, because we are told carefully the circles are congruent, that's great, but X is tangent to AB and AD. Let's say this is X and then this is A, B, and then A, C and D. So AB and AD, and then Y is tangent to AB. Maybe I should do it this way, AB, and then this is D. AB and BC, which is gonna be this circle is Y. And then the third one, Z, is tangent to CD, which is right here, and other two circles. These are good. But the problem is, the question didn't really tell the X and Y are tangent. So when you make them, those two are also tangent, the things will be weird, and then that doesn't really make any sense. So which is why that is actually not the case. So for that reason, let's think about actual figure that we really need to have. So which is why I kind of draw this a bit earlier. So then you could have the two circles are actually intersecting. So how do I know they are intersecting instead of having to separate circles? Because when you look at the distance from one end to other ends with the diameters, that will actually not going to satisfy the given condition. So for that reason, this is the only way that we can have that restriction. So let's now go ahead and start with labeling our centers. So I'm going to call these guys are this is A, this is B, C, and D. So then if you now connect the center points, right? So that will be the radius plus radius, which is 2 radii, and that's the same thing as well. But the third side is not going to be same as the other two sides. But still, if you take this one and then connect the tangency points, so you will get a perpendicular segment, and the same goes with this. So only thing that we really need to find out is just this part, right? Which is still height of the triangle, but it will not be really 36 and 90 anymore. Okay, let's try our best. Okay, so now, based on this, so I do have like this segment is R, and then this is also R, this is R, this is R, this is R, this is R. And I don't know actual this distance. So for that reason, maybe I should name some other segments as well. If I connect this, this is R. If I connect this, this is also R. And this part, so if I name this is like X, Y, and Z, the XY, the distance XY is equal to 6 minus 2R. 6 minus 2R. So if I take this point as H, like kind of height, so then this distance X to H or H to Y, XH or H to Y is going to be half of this number, which is 3 minus R. So which is good because we do know now these segments in terms of R, the hypotenuse is 2R. So if I just write this as well in terms of R, so we can use the pi tag. We know this is R, then this is R. So the whole thing, this segment is the same as BC, which is 6. So then we can say that the Z to H is equal to 6 minus 2R as well. 6 minus 2R. Now we have a right triangle, so we can just draw that and go with the Pythagorean. So let's go ahead and try that. So this is kind of our triangle in there. So this is Z, this is H, and this is Y, right? So this part H to Y is going to be 3 minus R, and the height is 6 minus 2R, and then this is 2R. So now you can use the Pythagorean. So the square of this 3 minus R, and then plus square of 6 minus 2R is equal to square of the hypotenuse. So if you use the square of binomial for this guy, so that should give us 9 minus 6R plus R squared. And then this is going to be 36 minus 24R plus 4R squared. And if you don't see this immediately, go ahead and write this like twice and multiply as well. So that should give us the same result. So this is going to be 4R squared. So these guys nicely cancel each other. So let's clean this mess. So we'll have R squared, -6 and 24 is add up to -30R. So that is 9 and 36 is 45 is equal to 0. So at this point, you can use the complete square or quadratic formula, but I will complete the square. So to do so, we are going to take this coefficient, linear coefficient, and divide by 2, which is going to give us -15. And we square that number, that's going to be 225. So R squared minus 30R plus 225. We got this after they had taken the half of this coefficient and squaring that. But we cannot change the question. We just subtract that number as well, and then plus 45. So these three terms is a perfect square, which is R minus 15 to the second power. And if you clean these two together, that's going to be -180. If you add to both sides, so you get 180. And now what we want is just the R, so we can take the square root. So the R minus 15 is equal to plus or minus root 180. And if you add 15 to both sides, so I should go this way. So the R would be 15 minus or plus root 180. So we have to be careful because since we are told the expression, the radius can be written as m minus root n, those m and n are the positive integer, which is, we have to take this. And then this is a positive version, but when you take this 15 plus root like 180, this is like already, this number is like larger than like root 169, which means this is larger than 13. So if you add 15 to 13, so you will get way bigger value than radius that we expect. because that should be somewhere like between 2 to 3 and stuff. So then this should be just in minus version. So that's basically what we are doing as well. So we are going to take the negative version. So 15 minus root 180. So then if you add this guy to this guy to get what we want, that will give us 195. So the question was a bit like confusing at first, especially how to start with the drawing. So for that reason, as soon as you start with something that you feel like that is the case, then go ahead and do something. And then at the end, just ask yourself, is that number that you got kind of reasonable for what you are looking for? If not, then take a look at your drawing and maybe change some stuff. So that is usually helps. So that was my kind of approach as well. So I hope that was clear. So I'll see you in the next video.